In Chapter 3, we're going to start talking about quadratics and diving into the details of what happens with those. But before we do that, we have to talk a little bit about complex numbers. You talked about this a little bit in Algebra 2. You might not have had a whole lot to do with it, but hopefully if you took math analysis, it kind of re-upped what you remembered about it and you worked with them a little bit more. So if I have a negative under a radical, that turns into an imaginary number. So I know that I is equal to the square root of -1, and you cannot ever leave negatives under radicals. So then we've got these 4 here. I have I is equal to the square root of -1. I squared is the number -1. If I have I cubed, that turns into I times I squared, so that is -I. And then I to the 4th power is the square root of -1 times -1, which gives me 1. So you're going to be required to do some simplification with these. So the first one we're going to do is I to the 18th power. And the pattern of how you do these is to write it as I squared, if it's even, and then 2 to the what exponent will give you 18. So that's going to be a 9. And we know from right up above it, you have -1 to the 9th power. And if I'm raising a negative number to an odd exponent, I end up with a negative, and 1 times itself is just 1. So -1 for that one. So then I've got a few more we're going to do. So 21 is not even, it's odd. So we break this down to where we have the 20th times the 1st power. Then we take I to the 20th and we replace it with I squared raised to the 10th power. And then we still have that last I. I know I squared is -1 raised to the 10th power times I. And a negative raised to an even exponent makes it positive, so this will just be the answer I. All right, so for I to the 45th, again, not even, so we have to break one of them off to the side. Then we write I to the 44th as I squared to the 22nd, and then I have an I here. So I squared is -1 raised to an even exponent is going to make it positive, so this one also is I. And then I to the 90th is even, so that's I squared, and that's going to give me a 45 out here. So I squared is going to be -1 raised to the 45th power, so that gives me a -1. Now you can also have -I as an answer. I didn't make one of those because I randomly came up with those exponents. So you have, I think, 2 or 3 of those on your homework of varying degrees for your powers of I. Okay, the next definition we need is complex numbers. So when I have a complex number, you're going to have A plus BI. A is the real part because it does not have the square root of -1 or the I that's with it. And then you have the imaginary part. So when you're adding and subtracting, as we're going to start off doing in these questions, you take the real parts and add them together, and then you add or subtract and combine the imaginary parts and combine those together. So highlighting, I have 3, and then this is a plus sign 2. So that's going to give me the number 5. And then we also have a positive 2 plus a positive 7i. So when I add those together, I get plus 9i. Notice that the exponent on I did not change because all we're doing is combining like terms. Next one, we're subtracting. My suggestion to you is to distribute this through. So I have 5 plus I plus 8 minus 6i. And then we collect our like terms. So we have real plus real. And then we have positive 1i minus 6i, and we can put those together. So we have 5 plus 8 is 13, and then we have 1 minus 6 is -5i. Again, exponent on I does not change, so that would be my final answer. So to multiply them, you have to either distribute or FOIL or box, whichever way you do it. And you cannot ever leave exponents on i's that are bigger than 1. So for this first one that we have here, we're going to take 2 and 10i, and we're going to multiply this by 8 times -9i. So 2 times 8 gives me 16. 8 times 10i is 80i. I have -9i times 2 is -18i. And then a negative 9 times a positive 10 is negative 90. I times I is I squared. And again, we cannot ever leave this I squared in here. So I know that I squared is equal to negative 1. So this is negative 90 times negative 1, which gives me a result of 90 down here. So as I write this out, I have 16 plus 80i minus 18i, and then I'm going to add 90 to that. And again, we're back to where we take the real parts together. So I have 90 plus 16 gives me 106. And then I take the imaginaries together. So when I take 80 minus 18, that's going to give me 62i. Notice again, I is going to remain I because I'm combining like terms. And also this I cannot have an exponent bigger than 1, so we have to change that to where it is only an exponent of 1, or even smaller and goes down so that it's just a negative 1. In the next little section, you're talking about complex conjugates, and these are formed by keeping the real part as is, and you're going to change the sign on the imaginary part of the given expression. So for this first one, it's going to have this line over the top of it. Okay, that means to calculate the conjugate. So the conjugate of negative 10 is still negative 10 because that's the real part and you keep it just like it is. So for this next one, we have again this bolded line above it. So 14i is the imaginary part. So to come up with the conjugate for that, the conjugate will give me negative 14i. Next one is a two-term. We have a binomial here. So I'm going to keep the real part, negative 2, and then I'm going to change the sign on 8i, and it's negative to begin with, so we change it into a positive 8i. And then we have this, 85i plus 58, and that conjugate will be negative 85i because that's the imaginary part, and then we are going to still be adding 58. Now the nice thing about what happens when you have a conjugate is that when you multiply these together, they end up getting rid of the imaginary portion. All right, so I'm going to keep the 11 plus 4i as is, and then this second one wants me to express the conjugate of that. So the conjugate of that would be 11 minus 4i. And now I'm going to multiply these together using the box or FOIL, whichever method you prefer. So I have 11 positive 4i, I have 11 negative 4i, and as I multiply these together, I have 11 times 11 is 121, 11 times 4i is 44i. Next one, I have negative 4i times 11, which is negative 44i. And then at the end, I have a positive times a negative 4, so that's negative 16. I have I times I is I squared. And again, we cannot leave the I squared. I know that that changes into and is equivalent to a negative 1. And that means that this last term turns into a 16. So what I'm going to do is write these down. So I have 121 plus 44i minus 44i, and then we're going to add 16 to that. And here we go with getting rid of the i's. Those two middle terms are going to cancel. So I have 121, and I'm going to add 16 to that, so that gives me a total of 137. The next thing we're going to deal with is that when you are given an expression, as you see here, you cannot have an I left in the denominator because essentially this is telling you that you have a square root in a denominator, and we know we have to rationalize in order to do that. So for us, what that means is that we're going to multiply by the conjugate to eliminate I in the denominator. So this is, I think this notation kind of lends itself to, oh, there's a line over that, so I need the conjugate. So the conjugate of the denominator is negative 4i. Now, I can't just multiply by that on the denominator. I have to do it also in the numerator. So essentially right here, what I'm doing is multiplying by the number 1. And in doing so, I have to be sure to keep these in parentheses. Across the top, I'm going to distribute, so I have 4i plus 4i squared, and we'll deal with that I squared in just a moment. And in the bottom, I have 4 times negative 4 is negative 16, and again, I have I times I. Now, I know that I cannot leave these I squareds, all right? They cannot cancel each other, but I am able to change them into negative 1. So this is 4i plus 4 times negative 1. And in the denominator, we have negative 16 times negative 1. So in the numerator, I'm going to put the real part first. So this is negative 4 plus the imaginary, so 4i. And in the denominator, I'm going to have the number 16. I don't know how picky it is online, but in general, what I tell students to do is to separate this into 2 fractions and then bump off your I at the end. And then what you want to do is reduce each fraction individually. So this is negative 1/4 plus 1/4 I. So that got rid of the imaginary portion that was in my denominator. In this next example, we have the same problem. So I have an I in the denominator. So I know I'm going to have to multiply by the conjugate of the denominator. And I will have to multiply top and bottom because this gives me the multiplication by 1. So the conjugate of 1 plus 4i is 1 minus 4i. And again, that has to be multiplied top and bottom. So as I multiply and distribute the negative 5i, I'm going to have negative 5i plus 20i squared. And I'm going to divide this by what I get when I multiply this out. If you need to do this on a scratch sheet of paper, you can. You're going to have 1 times 1 is 1. Then you'll have plus 4i minus 4i. And then you're going to have a negative 16i squared. And again, we know that we cannot have these I squareds. And very nicely, we can see that those two cancel each other out. So as we work through this, we're going to end up with a negative 20 because I changed I squared into negative 1. And then I'm going to subtract 5i in the top. Then down here, I'm going to have 1 plus 16, which gives me 17. So I have negative 20 over 17 minus 5 over 17i. Another set on the homework is going to tell you to simplify. So what these want you to focus on is the fact that you cannot have a negative underneath that radical. So you're going to have 6 plus, and you're going to change these so that you have the number under a radical and negative 1 under a radical. So this is going to end up being 6, and I'm adding the square root of 121 is the number 11, and then the square root of negative 1 is I. So this is my complex number that is a result. Okay, in the second one, I have the square root of 5 times the square root of negative 1. And then I'm going to multiply that by the square root of 125 times the square root of negative 1. So in this case, I'm going to have the square root of 5i. The I does not go under the radical. Be very careful as you write that. And then over here, I'm going to have the square root of 125. And it also will have an I beside it. So I multiply these two things together. So I have 5 times 125 is going to give me the square root of 5 times 5 is 25, 10, 11, 12, 5, 6, 25. And then I have I times I is I squared. The square root of 625 is the number 25. And I know that I can never leave an I squared in a problem. So I know that I squared is equal to negative 1. So my final answer for this one is negative 25. And then going back to really simple, we have the square root of negative 4. So you have to separate the number and the negative 1. And then we know that the square root of 4 is 2. And the square root of negative 1 is I. And that problem is now complete. See me with questions.